Good morning. Welcome to Currents Chem World. In this video, let us study chemoselective reactions. What are called chemoselective reactions? For example, it is simply, let us take this compound. It has two functional groups, alkene and ketone. When it is reduced by hydrogen gas in the presence of palladium as catalyst, one of the functional group is reduced. Okay, alkene functional group is reduced. Okay, so this selective reduction of double bond over ketone functional group occurs. This is called chemoselective reactions. We will explain further in detail. Okay, now what is selectivity of chemical reactions? There are three types of selectivity. We will see one by one. One is chemoselective. Which functional group is selectively reacting, preferentially reacting. Regioselective, the position, it indicates position or place. Stereoselective, how this stereoselective and stereospecific I have given in a separate video. Please watch that video. Okay, what is chemoselectivity? In this we'll see what is chemoselectivity. We'll explain with an example. Okay, as I said earlier in the first slide, if an organic compound contains more than one functional groups, okay, that are not equivalent, if a reagent reacts exclusively or predominantly with one of them, okay, and the reaction is said to be chemoselective. That means in a compound you have two functional groups, okay, but one of them is reactive, okay, predominantly reactive, then the product formed will be chemoselective. Okay, or in other words, chemical reactions have preferential selectivity towards one functional group over the different functional group. You may have two different functional groups, completely different functional groups, or you may have similar functional groups. We will see with examples. Unequal reactivity, in other words, you have two functional groups of unequal reactivity of one of the two identical functional groups. Okay, chemoselectivity occurs due to preferential selectivity of one functional group over the other different functional group, or unequal reactivity of one is 100% reactive, another is 50% reactive. Okay, then also it is termed as chemoselective reactions. In this we will see two examples. Let us see the first chemoselectivity reaction in the case of reduction of carbonyl compounds. Okay, let us now consider an organic compound with a single functional group. Okay, for example, single functional group, 2-hexanone, okay, is reduced to 2-hexanol by sodium borohydride. In this molecule there is a single functional group. Okay, there is a single functional group. Similarly, in hexanoic acid, in this molecule there is COH functional group which reacts with the sodium borohydride to give hexanol. Okay, here there is no chemoselectivity. We will see next. Okay, now consider an organic compound with two different functional groups that is a keto. You see here, this is 5-oxohexanoic acid. This compound is called 5-oxo. Okay, 1, 2, 3, 4, 5. 5-oxohexanoic acid. This organic compound consists of two functional groups. Okay, one is a ketone functional group, another is, both are carbonyl groups, carbonyl functional groups. Okay, these are all carbonyl group functional groups. Okay, now with the sodium borohydride in the presence of solvent ETOH, ethanol, as you see, this functional group, ketone group, is only reduced. Keto, CHOH. Okay, in this reaction with the sodium borohydride, only keto group is reduced. You see here, with the lithium tetraaluminum hydride in the presence of THF tetrahydrofuran as solvent, both the functional groups are reduced. CO group is reduced to CH2. Okay, both the functional groups are reduced. Therefore, in this case, selective reduction of keto group over carboxylic acid functional group. Okay, in this case, both of them are reduced. There is no chemoselective. This reaction is not chemoselective, whereas this reaction is chemoselective. Selective reduction of keto group of 5-oxohexanoic acid with the sodium borohydride occurs. Okay. Let us see the second example, chemoselective reduction of C double bond C over C double bond O. Okay. Now, let us consider alpha beta unsaturated cyclopentanone. This compound is called alpha beta because this is alpha and this is beta. With respect to this CO group, this is alpha, this is beta. Alpha beta unsaturated cyclopentanone on reduction with the hydrogen palladium as catalyst, hydrogen gas palladium as catalyst. Okay, it gives cyclopentanone. In this reaction, okay, this reaction is selective. This reduction is selective for C double bond C reduction. Okay, selective reduction of double bond occurs but not ketone group. Thank you for watching. Please share and subscribe. Thank you again.